I am going to have the pleasure of introducing Tim McKay, who is someone who I started working with the past year. He is a professor of physics, astronomy, and education at University of Michigan. And while he may have a history of sort of being a scientist, right? It turns out that one of the ways that you be a scientist is you collect data and you look at it and try and make sense of it. And he came to realize, especially when doing big data astronomy research, that big data and looking for interesting trends and patterns and outliers gave him just exactly the right skill set to look at the big data of students learning on campuses. And he realized that there was a great opportunity to take those skills and apply them to the way we are thinking about working with campus data to improve student outcomes. And so when we joined the Big Ten, and thus the CIC, which is the academic sort of side part of Big Ten, it turns out that had great benefit. There are all kinds of really exciting collaborations among the 15 CIC schools, and one of them was that we joined this group that Tim created, which was a collection of CIC schools, to start to look at some learning analytics data. And he got a bunch of schools to sort of try to think a little bit more coherently about what kind of data you could look at and what kinds of things you could do. And he collected a bunch of people, including me at Maryland and a bunch of people in this room, to start to look at, see if we could more programmatically find issues of bias, structural bias in teaching, where maybe different genders were having different outcomes that we didn't recognize, that you couldn't see by looking at the small, but you might see by looking in the big picture. So he's certainly done a good job at opening my eyes. He actually came to campus a year ago to talk to a smaller group, and he did such a good job that I invited him back. So I hope you'll welcome me to as Tim comes up. Thanks.
All right, let me start by saying it's a real pleasure to be here, to have the opportunity to talk to you at a campus-wide meeting like this. We do some meetings on the University of Michigan campus like this. They're always very energizing. I find out just what great ideas my colleagues have. Almost always the problem that I bring to the table, someone else has already solved. And having the right kind of communication is really crucial for understanding them. What I want to do today is to talk about learning analytics in a kind of broad form, to show you a few examples of things we've done with learning analytics, maybe to work to define it, to get you to think about it in different kinds of ways from the way that you might already. And I want to start with this Wordle that was put together, this word cloud, that was put together for an ELI Learning Analytics 3-day sprint in 2012, right sort of at the start of people using this terminology. And it has a lot of things in it that we all really care about. It talks about learning, it talks about students, about interventions, courses, and so on. And I'm just pleased that even back in 2012, Michigan got in here as a tiny little corner of this. So let's start by talking about definitions, about what learning analytics really is. So when I am trying to figure out what something really is, I go to the internet like anyone else. And one of the places that I go to learn about the origins of words and phrases is the Google Ngrams system. So if you go to the Google Ngrams system, you can put in any word or phrase up here in the box, and it will tell you where in the 14 million books that Google has scanned that word and phrase appears, all the way back to 1800. And you can go and see all those appearances if you want to. You can see how words change and so on. So if you look up analytics, for example, you'll see a figure that looks like this. It's a rare word for most of its history. There's an interesting little bump back here in 1810. That's when the subject of analysis entered mathematics, right? It was a new topic at that time. And then it burbles along until you get to about 1995, and then analytics takes off. And you all know that analytics is a big topic right now. In Google Ngrams, you can search from 1800 to 2008. So if you put in the phrase learning analytics, 2 words sitting next to each other in 14 million books, and you look it up in Google Ngrams, it never appears. So whatever learning analytics is, it's new, right? I was amazed. I've checked it 3 times. It's really true. So You can go somewhere else and ask the Google, go to Wikipedia, and you will find a definition of learning analytics that actually emerged from the Society of Learning Analytics Research in about 2011. So they would say learning analytics is the measurement, collection, analysis, and reporting of data about learners and their contexts for purposes of understanding and optimizing learning and the environments in which it occurs. Okay? So I want to pick apart that definition and make comments on a few pieces of it. It's a very good working definition. So first of all, this is about measurement, collection, and analysis of data. Measurement of data is about having an instrumented world. A world in which when things happen, something is recorded about them, whether a person does the recording or not. Right? Having an instrumented world is crucial to every bit of science that I've ever done. We wouldn't know anything about astronomy if we didn't build instruments of these kinds, and they weren't able to show us things that we couldn't otherwise see about the world. So instrumenting the world, thinking about our education system as being instrumented, always collecting information so that we can learn from it. The collection part is really important, and it's what makes learning analytics happen now more than it did in the past. And this is because digital tools are able to remember faithfully everything that is recorded. They are very tireless in their ability to remember an awful lot of information. So while I might think back about my course last term and remember a few incidents that took place in that course that I want to learn from, I will not remember what happened on an everyday basis. But digital tools can do that. They're also good at analysis. They're able to actually look at much more information than I could and digest it in ways that I teach them to do so. Right? I mean, they're not doing anything I haven't asked them to do, but they're doing things at a scale that I just don't have the patience or time to do. So all those things are important. Reporting of data is really essential. This is, I think, the central thing about learning analytics. We want to use the data that we have to inform everyone who has questions about teaching and learning, everyone who has something to learn about teaching and learning. So that can include obvious targets like faculty and administrators, but it also includes people like staff members, the public, parents, and the most important audience for learning analytics really is students. Students come here, they're desperate to learn how to be a successful student on this campus, to figure out what it is they should do, and they have the least amount of information. So I think they have the most to learn from what we can do with learning analytics, and I'll try to keep that focus on them in a couple of different places. Okay, so we got through the first few words of this definition. Let's go on. It's about data, about learners and their contexts. And about data, I would like to say that data is not always what you think it is. It's not always numbers. It can be other much richer things. It can be the fact that your learning management system actually collects and maintains a collection of everything that students write in your class. So it might be possible to look year over year at what's happening with student writing in a way that used to be impossible. That writing is data as well. It isn't just sort of simple numbers. It can be other things. Who are the learners? Well, the learners, of course, are students on campus and off, but it's really everybody else, too. We're trying to learn about how to do what we do, so the whole community of people come into that. And then they carefully inserted this word context in the definition, and I think that's crucial because contexts are essential for understanding learning. Analytics are often accused of lumping everyone together and generating an average kind of thing. That's a big problem for learners because they're not all the same. So understanding context requires that we really think in a really broad way. Then what the purpose of it, for the purpose of understanding and optimizing learning and the environments in which it occurs. So there are dual goals here. One of them is to understand teaching and learning. It's kind of a research goal. But the second is to actually act on it, to make teaching and learning better, not just to have teaching, do research studies, but actually to change the ways and the efficacy of the teaching that we have. The environments are really crucial. Learning is a human process. It's very much affected by the environments in which it happens. It's very much affected by context. And so when we do learning analytics, I don't think we're looking for universal laws of learning. We're trying to understand the interplay between environment and context and learners so that we can optimize learning in a way which is different in every place. I'll give you one simple example of this. Personalization plays a really big role in the work that we've been doing at Michigan, thinking about how to personalize education. And that is a totally moving target. When we started doing it, any indication to the student that something they were receiving from us was personalized was very powerful. because they'd never seen something personalized before. But after you do that for a little while, that impact fades very rapidly because now they know, oh yeah, I get personalized things all the time. That's no big deal, right? So with humans, humans are always responding to the environment. And this will never be a task that's over where we like figure out the right way, right? It's a constantly moving target. It's a thing we need to attend to all the time. All right. And I think fundamentally, the ability of learning analytics to expose to us information about every student so that we know more about where everybody is, about what everybody needs, about how to work with each individual student is crucial, especially as our community becomes increasingly diverse. Okay. I want to tell a little story about the origins of learning analytics at Michigan. I have been investigating this in a variety of ways to try and understand how and when and where we've used data in the past at the university. I have to say I'm aided in this by the fact that my wife is the lead archivist for university collections in our Bentley Historical Library. So she regularly comes home in the evening with a new pile of documents to expose to me the ways we've used data in the past. So let's go back to the beginning. When we started to quantify our education at Michigan was in 1912 when we adopted letter grades. Prior to that time, students at Michigan received grades of passed or not passed. Nobody ever even failed. It really was a mastery teaching environment, right? If you didn't pass this term, okay, just do it again, right? It was a really different environment, okay? But in 1912, we decided we had to have letter grades, and the reason that letter grades were introduced was so that we could select the most distinguished students on our campus for a Phi Beta Kappa chapter. They wanted a Phi Beta Kappa chapter. They couldn't have it without a system for selecting students. We got grades as a result. So after their first year, when they introduced grades, the university released a report on the grading system for that academic year. And in this report, what you will find is for every single instructor, exactly what grades they gave out, right? How many A's they gave out, what percentage those were, and so on, going through the whole list for all these different things. This was released to the whole faculty, given out. You know, there was a new thing. They wanted to make sure they were doing it right. Now that it's an old thing, we don't care whether we're doing it right or not, right? We just do it. But it's pretty cool to see. It turns out that this was a time when people were paying a lot of attention to these kinds of data and to analytics. And when the first university vice president at the University of Michigan was created, that man was Clarence S. Yoakum, and his title was Vice President for Educational Investigations. The very first vice president at the university was charged with doing these kind of things. Some of you, if there are any social scientists in the room, you may know Clarence Yoakum's name. He was also responsible for implementing the Army testing program during World War I, which gave us IQ tests. And in fact, a lot of the modern world of standardized testing, Yoakum was responsible for. He kept this title until 1945. And I love this picture. You know, I'm a physicist, so I love this picture because it's got Werner Heisenberg in there, and Gauss-Schmidt, and Enrico Fermi. They continued doing this kind of work for a long time. This is from January 1931, and it's looking at the correlation of grades of students in their first semester with later semesters, and it includes this whole nice table. So first semester with second semester engineers, the correlation in 1926 was 0.7. In 1927, it was 0.696, right? This was the kind of stuff that was being regularly reported to the faculty in these kinds of reports. They also did extensive studies of admissions, and so here's a Clarence Yoakum report from 1936. It says inside it, the total result indicates most strongly that there's a large element of chance in the selection of individuals for college entrance. This result might be expected since grades for different years in college correlate for the most part only in the 50s. And they looked at 10,000 students over a decade. They were really examining their own admissions criteria, and perhaps they stopped doing that because they realized it was much more of a lottery than they wished to share with everyone. This kind of work continued at Michigan all the way up until the early 70s, and the kind of last gasp of it is this report, which by the 70s had kind of changed in tone, grading, testing standards, and all that. Right? It was a little less formal. The guy, Benno Fricke, who did this, ran our exams and evaluations office. He was a very good social scientist. The report's full of really great stuff, and it has this total tone of no one's paying any attention to this anymore. Really interesting. So we have this history. It kind of fell apart at some point, and data languished for about 30 years on campus. I think that a lot of thinking in the academy moved away from that kind of approach. So there were several decades of relative disregard for data. Interestingly, these were just the moments when computers appeared on campus in this same period of time. So at Michigan, this was reborn when the university created a data warehouse in 1996. This data warehouse is used to store all kinds of student record data, admissions files, graduation records, everybody's transcripts, and so on. And at this point, it contains the full career information for more than 100,000 students. It's quite an amazing archive of information about what's happened. Not long after the data warehouse was created, some of my faculty colleagues recognized how valuable it might be to provide access to that information to faculty members and staff members and eventually even students. And they created something called the Academic Reporting Toolkit in 2002. Very simple window into that data so that people could ask and answer their own questions. As it turns out, the university wasn't ready for that in 2002. One of the first things that happened is a faculty member looked up the grades being given out by his colleagues and then went from office to office to tell them how they were doing the wrong thing. Right? You're giving out grades that are too high, they're too low, whatever, right? And the university wasn't ready for that kind of openness then. So things stayed stalled for a little while. The other thing that happened in the mid-2000s is that digitally mediated instruction really took off. We got learning management systems and things like that. So now that many of the activities that are involved in instruction happen through digital media and consequently can be captured and data can be produced by them. So both of those things played a big role in getting things started again. There were two kinds of activities in the late 2000s that were happening on campus at Michigan. One was through an organization called the Use Lab, led by Stephanie Teasley and Steve Lawn in our School of Information. And they started looking at LMS data. They said, oh, well, we've got this LMS system. We should find out what's going on in it. They looked at usage. They tried to understand how some of that stuff might relate to student performance and so on, looking at click streams and activity, stuff like that. On the other side, in the physics department where my colleague Gus Everard had built this academic reporting toolkit, we started looking at the data from the student record system to understand the performance of students in our introductory physics classes. We made efforts to understand how preparation relates to performance in large introductory courses. And I met Stephanie Teasley in November of 2010, and we started talking about doing a larger thing with learning analytics at Michigan. And we launched something called the SLAM seminar series. And in a certain way, this is a model for how to get teaching conversations going on a campus. You know, we know how to talk about academically interesting things. We set up a seminar series, and we get together and we talk about them. And so that's what Stephanie and I decided to do. Originally, we proposed this as an academic analytics seminar. Remember, it was happening right when learning analytics was emerging as a name. But we really didn't want to run AA meetings every week. So instead, we called it the SLAM series. And these SLAM seminars stood for Symposium on Learning Analytics at Michigan. And the goal was really, you know, this is actually the slide from the very first seminar that I gave in this series. And they began in fall of 2011. And the point was to bring together people interested in understanding the university with data. That was the whole point. And so if you have people who are interested, for example, in understanding active learning or flipping the classroom, you know, maybe you just set up something like this and get people talking about it. It's a very effective thing to do. Many of the speakers were from on campus, but we also brought people from off campus as well. It's a relatively cheap way to build up a lot of activity. Now, those conversations began to spread. And the way they spread is that they went into this Academic Affairs Advisory Committee, which was working for our then provost, Phil Hanlon, now the president at Dartmouth University. And it led to the creation of a learning analytics task force. Our provost recognized that there was a lot to be gained by looking at data to understand teaching and learning, and he wanted us to go to work on it for a while. So he created this learning analytics task force with a charge that's written up here on the right-hand side. The basic goals were to work on the environment for doing this, make sure that information we have is available to people who have good questions to answer when they should be answering them, to make it a really good, easy place to do that. He also wanted to foster the creation of projects and some building of expertise in learning analytics by getting some projects funded. So he gave some money to support projects which would be funded, and then asked us also to review the metrics to assess teaching and learning at Michigan. The nature of this committee was also crucial. It was a committee of faculty members from across the institution, some of them education researchers who had real expertise in doing this kind of work, some of them teachers who were really engaged with their students, and some of them data people, people who really built big databases and so on. Most of them had not been deeply involved in this conversation when they were asked to serve on this committee. So they brought in with them connections to other places it's real easy in a lot of these conversations to see all the usual suspects every time. So some work to try and get beyond the usual suspects is really important. The first thing that the Learning Analytics Task Force was about building community for learning analytics at Michigan. And I want to talk about a couple of different ways we worked on doing that. The first thing I did was to adopt the SLAM seminar series and keep it running. We had our Center for Research on Learning and Teaching adopt this series to help us execute them. And last year, the SLAM seminar series had about 660 people come from 15 of our 19 schools and colleges, which is pretty good reach for our university. We have always videotaped all these talks and put them online along with all the slides and things so anyone can go and see them, and this has been useful nationwide. We had about 9,000 hits on this system last year. This gives a lightweight introduction to learning analytics to a lot of people, but some people wanted to go deeper. They wanted to learn more, and we needed to provide them with some structure for doing so. So we created something we called the Learning Analytics Fellows Program. It was basically a class. So we set up a fellows program which would bring in faculty and graduate students to meet for 2 hours a week in an academic kind of way to work on learning about learning analytics. We put data together into their hands so that they could do projects. And this turned out to be really a watershed for us because suddenly we had 30 or 40 people working on learning analytics projects, and they discovered all kinds of things that we would not have gotten to for years, no doubt, right? So giving people the space to work on it and supporting them for doing it was really key for us. I'm going to mention 2 examples that came out of this Learning Analytics Fellows project. The first one about using placement exams to put students in the right place at the beginning of their time on campus, and the second about program evaluation for our Health Science Scholars Program. Okay? So the first of these was done primarily by Ginger Schultz, a presidential postdoctoral fellow in our chemistry department, and it involves our very elaborate chemistry placement system at Michigan. I don't know how many chemists we have here in the audience, but Michigan has a kind of unusual model which allows many students when they first arrive on campus to go directly into organic chemistry. On most campuses, you would take general chemistry first, maybe even 2 semesters of general chemistry, and then do organic chemistry. So in order to sort that out, instead of doing this 2 semesters of general chemistry, 2 semesters of organic chemistry, students coming out of high school chemistry at Michigan, if they get AP scores that are high enough, go directly to organic chemistry. Otherwise, they take placement exams, and then they are sent either to organic chemistry or off to general chemistry for a semester, and then back to organic chemistry. So obviously, the purpose of this system is to correctly send people along the right path. That's its intent, is to make sure that people go in a way that will be successful for them. In particular, when people are sent onto this longer path, the intent is that it would really improve their performance here. Right? That's the idea. That's why they're being asked to do it, because people think it will lead to a much improved performance in the second class. And this analysis aims to probe whether, in fact, it does or to what extent it does. All right? So this analysis is done in a form that's called a regression discontinuity analysis. And it basically relies on the fact that if you have a chemistry placement rating for every student on campus, then you have some kind of idea of how they would do in that subsequent chemistry class, right? There would be some relationship between that chemistry placement test score and their grade in the class. If then you stop at some particular point, a discontinuity, and say everybody on this side is going to have a treatment, they're going to go to that first class. They're going to go take general chemistry first. Then you should see their performance in the subsequent class actually go up because you did something to them. You changed it. So regression discontinuity analysis basically relies on the idea that around this boundary, the students are really kind of the same. So even though you didn't do a random controlled trial there, they are kind of randomly sorted across that boundary. And it allows you to probe this very carefully. So Ginger and her colleagues did a really nice analysis of this. And what they found is that taking that first semester general chemistry class leads to an improvement in subsequent performance of about 0.2 letter grades. So that's good. It's a positive effect. But it's not nearly as big as most people were kind of maybe imagining. When they sent people off to take this Gen Chem class, they kind of felt like if you didn't do that, it would be really bad. But this data doesn't really support that. It says if you didn't do that, you would do slightly worse. Meanwhile, the students have spent another full semester taking a big introductory science course, which is not a very friendly environment in a whole bunch of ways. They're a semester behind a lot of other students. So this is making people really rethink the way we do the advising around this. You know, there's an effect there, but that size of that effect is important. The other thing that's not accounted for here is that the students who take the general chemistry class first, when they take the subsequent class, they're older students. And students' performance actually improves while they're on campus. And that hasn't even been taken out here. So it's actually possible that this effect is even smaller. Right? So by looking very closely at a very consequential thing, 1,400 students a year are getting, you know, going one way or another in this. It's a big deal. We can pick it apart. So that was one example. A second example is a kind of program evaluation. We have many programs on our campus that aim to improve the experience and the outcomes for students on our campus. A good example is the Health Sciences Scholars Program. This is a living learning community for people who want to go on and become doctors. Right? We have a huge number of students like this at Michigan. We produced about 750 medical school applicants last year. So a big part of our campus. And the question, the research question really was, how does participation in the learning community impact student outcomes? And they were particularly interested in at-risk groups, first-generation students and ethnic minorities. All right? They've done lots of things in the past to evaluate satisfaction with this program. Everybody loves the program. They wanted to see how it really impacts people. So the approach taken in this analysis led by Chris Brooks at the university was to do a matching analysis. The basic idea of this kind of matching analysis is that you have a very large pool of people on your campus. They occupy a whole space of different student properties. Some of the people then participate in this program. If you can find other people who are very, very similar to them on campus, according to all the parameters that you know about them, and then say some of those people got the Health Science Scholars Program, some didn't, what's the difference in their outcomes? Right? A very standard kind of quasi-experimental design method used in social science now. And because we have a lot of data about the students, we can really match them in a whole bunch of ways, on test scores, but also on which school and college they're in. Are they in at-risk programs? You know, what's their citizenship, ethnicity, self-identification with being interested in pre-medical programs, family income, all kinds of things, right? So you have a pretty good idea what these students are like. When they did this, what they found is that if you look globally across the program and ask, what is the change in probability that a student will complete an undergraduate degree in science, receive a master's degree in science, or go on to an MD or PhD program? If you look at the whole program averaged together, you don't see an impact. No statistically significant difference. The students who join this program, they want to be doctors. They like being in the program. They become doctors. The students who don't join this program, they want to become doctors, and they do. Right? But if you look at some subsets, if you look at underrepresented students or first-generation students, you see quite significant increases in their probability. Those increases are washed out when you look at the whole program, but they're not when you pick it apart in this way. So just to give an example, asking about underrepresented students who went on to complete an undergraduate degree in science, in the group that actually participated in the program, out of 127, 67 of them received science degrees. In the matched group, out of 127, 47 received science degrees. Right? So you can really pick this kind of thing apart. So that's an example. Along the way, while we were doing this learning analytics work, something came along that was a surprise. I don't think anybody really expected to see this MOOC phenomenon happen in 2010. We didn't know it would be going on. Michigan joined Coursera as one of the founding partners in early 2012, and since then, there have been a bunch of MOOC classes at Michigan teaching more than 2 million students. Typically, only about 10% of those students complete the classes. Interestingly, when the MOOC started, everyone thought they would be the perfect environment for learning analytics, because everything happens online. The problem is the only thing that happens online is the course. Right? Here on campus, when we do learning analytics, we know a lot about these students. It's not just what happens in the course. We know who they are, where they're coming from. We know about what else they're doing. And all of that context is hugely important for really learning something. So as it turns out, MOOCs are not really a great place to do learning analytics research. You're doing something different. Understanding MOOCs, maybe, but you're not doing the kind of learning science we'd really like to do. That may change, but right now that's where I see it standing. We are engaging in a MOOC, however. We built this Learning Analytics Fellows program, thought it was really valuable for us to get a bunch of people thinking and talking about learning analytics. When we began our conversations with the CIC, there was a move to expand it. Let's do a Learning Analytics Fellows program for all our universities. And our thought at the time in 2010 or 11 was, oh, we'll do a summer school. We'll fly everybody to Ann Arbor, and they'll spend a week together. But that's actually really hard in a whole bunch of ways. So instead, what we're doing is we're creating a MOOC that should launch sometime this summer on practical learning analytics. An ideal way to participate in this MOOC is to get a bunch of people on your campus together, and each person do a little part of it. And then you talk about it. And then it would be just like the Real Fellows program that we had. We're trying to set it up like a smorgasbord with choices of participation levels. So you can come to our smorgasbord and just have a cocktail. It's fine if that's all you want to do. You would be a success if you did that. You could want to have a snack. You could want to have a whole full course and so on. So it's meant to be a course that will work for people at different participation levels. And the goal of this course really is to kind of collectively ponder this topic. To keep it practical, we're going to focus on traditional student record data because every university has that kind of data. Right? It's fairly accessible on most campuses. To make it interesting, we're going to try and address questions that are raised by an array of stakeholders, including students and faculty and staff. So there will be kind of different audiences considered in this. And to provide some analytic teeth for this, we're going to provide each example both with realistic data and with code that you could just run on that data, right? So that's the way we ran our Fellows program. We want to do the same thing here. So I'll make sure that everyone here at Maryland gets to hear about it through Ben when we're finally ready to launch it. The other thing we've been doing to try and make learning analytics really stick is to treat it like we treat everything else on campus. You know, when we raise questions and we learn something new, it's research, it's scholarship. We want to treat it that way. So we're participating in a research community that goes beyond campus. A good example of this is the Society of Learning Analytics Research, and this is an image from the recent 2015 meeting. Michigan is a founding member of this solar organization. Stephanie Teasley is on the board, and this is our famous Dr. Chuck Severance giving one of the plenary talks there, mentioning some of our tools. And we had this fun event, you know. We had a bunch of people from Michigan there, so we had a maze out. And we got everybody to put on their yellow T-shirts for the poster session and convinced everyone that we were a dominant force in learning analytics research. It was fun. OK, so that's one thing, building community. A second thing is working to open data for use, both on campus and off. And I want to talk about that a little bit. The Learning Analytics Fellows program really helped us bring data together and forced us to think about how we make data available to people on campus. So we developed a very simple MOU process for data access on campus as a quick solution to how to get data into people's hands. It's a really simple form that people fill out. You know, it says Learning Analytics right on the top of it. It says, as a prerequisite for receipt of data, the researcher must submit to the Office of the Registrar documentation of an IRB application, right? So we just asked everybody to do IRB. Really straightforward kind of system. It got us started. As things go along, that system may adapt, may become simpler, right? But for the moment, this was the way we did it. Our Vice Provost for Digital Education, James Hilton, and his Office of Digital Education and Innovation is creating new campus-wide privacy statements. And the essence of this statement is to say that you need to know when you come to this campus that we gather a lot of information about teaching and learning. And you need to know that we're going to use it to understand teaching and learning and to make teaching and learning better. Right? We want to make sure people really know that. This should be a kind of front web page of the university kind of statement. The other thing that's happened is through the course of all this work, we created a lot of personal connections between people who are controlling data sets, right? So that they could work together in a way that they never had before. And right now, they're working on what we're calling a learning analytics data architecture to create a really clean version of all the data that's on campus that would be useful for asking and answering research questions. And it's right down at the detail level, so you're not supposed to be able to read this, but they're actually trying to understand every single parameter they would put in and where it comes from and how they would use it, right? So all that's been very helpful in opening data on our campus. Opening data beyond campus has been coming about by having conversations between institutions. So in the summer of 2013, our provost asked me to go talk about this Learning Analytics Task Force to all the other CIC provosts. And the great thing about talking to provosts in one room is that if you tell them they should do something and they kind of look around at each other and check it out, right? See, are we going to do this? And then they can just say yes, because they're in charge, right? So they endorsed, you know, some first effort to do this. They said, yeah, go ahead and do this. And that made it a lot easier for us to get something started. So they endorsed the idea of doing some CIC-wide comparisons. We went to the Sloan Foundation and got some support for this, and last November, we held a meeting in Ann Arbor where we actually, for the first time, showed analysis results from a whole bunch of our campuses, and we're able to make comparisons of the kind that Ben described to you. We're now working on bringing those comparisons together, making them really careful and mature, differences in what we call grade penalties and gender performance patterns across a whole bunch of institutions, and thinking about publishing a paper about that. So we're having some collaboration between campuses. None of it is at the data sharing level. No one has sent any data from one place to another yet, although we hope we will get there. What's happened so far is sharing analysis results. So we're thinking now about building a bigger research archive, something that might include data from not just the CIC universities, but something bigger, and that might give us a multi-institutional portrait of the impact of research universities. So what do we do at research universities? We teach and we do research. If we had data about those things in an archive, we could all understand the nature and the impact of research universities better. This may be a longer-term thing to pursue, but it's something that we're working on right now. There's already a start on it being done on the research data side. The Institute for Research on Innovation and Science at our Institute for Social Research is now gathering information about research expenditures on many universities. We're hoping to add learning analytics data to that. Part of the goal is that if we could add those things together, we believe we might be able to then connect those learning outcomes to people's career outcomes later in their lives. Something we've all wanted to do for a long time but found very difficult by doing surveys and things like that. Okay. Lots of effort going into putting the data to use, and I want to talk about that as well. The Exploring Learning Analytics projects that we funded at the University of Michigan helped us to create a bunch of interventions that aim to use data to go and work with students directly. One of these that I led was called the eCoach project, and eCoach uses computer-tailored communication software to be able to look at a very rich portrait of what a student looks like in data. And then it allows us to say to every one of those students what we would say if they were sitting in front of us, but we don't have time to talk to all 700 students in the class. So it basically allows you to write the kind of messages you would like to send to every single student based on data about them, and then deliver them. We've used that for a kind of personalized coaching system that helps the student understand where they stand in a class, what they should be doing, whether what they're doing is working, and so on. Another example is the Student Explorer system. This is really a data aggregation system. What Student Explorer does is bring together data with a whole portrait of the student and make it available to an advisor. So an advisor can know whether a student is struggling in all their classes before they receive failing grades in all their classes. So this is a kind of early warning system. A fascinating system that I'm really excited about was created by my colleagues Barry Fishman and Mika Levac-Monti on our campus. It's called Gradecraft. And Gradecraft is kind of an alternate LMS that allows you to create a really game-inspired class. In one of the sessions I was in this morning, people were talking a lot about student agency, the importance of students making choices about what they do in class, and Gradecraft takes this to the nth degree. It basically says you start out in class with no points at all. You start out with 0, and you have to earn your way toward the grade that you want to receive. There are a bunch of ways of earning your way toward that grade. And you actually have to make choices about what you're going to do in the class. You're not just allowed to make choices. You're forced to game the system. So a student has to think about what they want to do in the class instead of just being told what they're going to do in the class. Very cool system. All right. We've been thinking a lot about how to take these digital tools, which this little grant program allowed these tools to get to the point where they function and where we can test whether they work, but they're not ready for prime time. You can't just hand them off to infrastructural IT people and have them run them. They're put together by graduate students. I mean, the code has duct tape on it, right? You know, that's the way things get built in research groups. So we have to cross this valley of death between innovation and infrastructure. We needed a place for good ideas to take hold and cross-fertilize and so on. And we want both to be able to grow them as on-campus things, but maybe some of them should turn into commercial things too. So we're just now creating something called the Digital Innovation Greenhouse. And its fundamental goal is to increase the use of personalization at scale. We're doing this with a Third Century grant. Our university is about to celebrate a bicentennial and has put $25 million into teaching efforts for that purpose. And it's allowing us to build a team of developers whose goal is to move things from innovation to infrastructure. These people will work very closely with the researchers, with the communities of practice who are using these tools, and with the IT people. All right? Their initial tasks are to build out and combine Student Explorer and eCoach. for personalization and to oversee the creation of a next-generation academic reporting toolkit. And I'll tell you a little bit about that in a second. They need to work really closely with communities of practice. Another problem with researcher-created tools is that the researcher creates the tool for themselves, right, for their problem, and it's not always the tool that you really need all across campus. So you need to engage feedback from people in order to do that. So the DIG team looks like this. I am connected to the team of innovators that are out there on campus. Mike Daniel is the administrative operator of this system. He works in the Office of Digital Education and Innovation. And Rachel Niemer in our Center for Research on Learning and Teaching is connecting to the communities of practice. There's a core set of developers in the middle of this system. I'm happy to put their faces on this because they all accepted their jobs 2 days ago. So it's pretty cool. We want really to leverage the youthful talent on our campus, so we'll be working with graduate students and teams of interns as well. We've already done some hackathons and design jams around this, and when you open up the door to let students think about what they'd like to see or what they'd like to do, you get lots of fascinating stuff. So we're aiming to do that. So we'll be reaching out to innovators, the communities of practice, and eventually to the IT infrastructure side. That's the idea of this team. Where I think this is all headed is toward a new view. In the past, all of these tools like Gradecraft and Student Explorer and eCoach hold their data inside themselves. Right? They have to build their own data system inside themselves. And that means that they don't exchange their data very freely. So where I think this is headed is toward a kind of cloud-like view where inside this cloud, the university will maintain a comprehensive and extensible and accessible portrait of every student, so that applications can either take data out of that when they need to know something about the student, or put data back in when they learn something about the student, and all of it will be accessible to these tools in this kind of way. When they're our tools, this will definitely go both ways. We'll pull information in and out. When they're outside tools, like Canvas or some other commercial tool, we will insist that those tools put their data in. We may or may not let them take any data out. It depends on what kind of relationship we have with those companies, right? But this kind of vision that we will be building a thing that allows us to bring things together and that all these tools will be able to interact with it is, I think, the direction that we're headed. I like this image of a cloud, not because it's in the cloud, I don't know where it is, but because we have no idea what it is yet, right? So something that looks a little blurry is probably the right vision for it at this point. Okay, I wanted to say a few things about this ART 2.0 system because I think it's going to be really interesting. We're basically going to provide a window into data that will reach out to students and faculty and staff and administrators and let them answer questions that are sitting there in the data. This has been something we've been aiming to do ever since the first ART 1.0 system was built, and we're going to do it right now. Let me give a few examples just to give you a sense of what students might want to know. When students go to register for a class, they'd love to know more about the class, right? We have all kinds of information about the class that we're not sharing with them right now. We might be able to tell them, for example, who takes this class? What do they go on to major in? Is this a kind of class that's taken by people who go in a direction that's important to me or not? So here's an example of a figure that might do that. This is for our introductory physics course. And these are all the different people who take that course. And in this visualization of it, we've also shown them what the average grade those people receive is. I don't know if we'll do that, but we could. Right? So this would tell them something more about a course that they're thinking about taking. They might also ask, what kind of courses do people like me take? So I'm trying to plan my path. I want to do the kinds of courses that a physics major might do. So I might like to know, what courses do physics majors take? So we could show them that. Right? Here's all the courses that physics majors have taken in the past with at least 10 students since the fall of 2007. And again, what courses have they taken and how have they done in those different courses? Views that they might like to see. We would like students to be able to understand their own position and status in the university in different kinds of ways too. I'm going to talk about this just a little bit at the end, but let me show you an example of something we might show them. How are they connected on campus? So for a student to be able to see, I know you can't really read any of these details, but what it's showing is how are economic students connected to other disciplines on the campus? So they might like to know, among economic students, am I really widely connected on campus or not? Am I living an isolated life compared to other econ students, for example? And we can show people this kind of information, making new measures of the intellectual diversity of a student's experience. All right. I'm going to finish up by saying a few words about how we can use existing data in new ways. for us to better understand the student experience, and also then to change some of the motivational schemes that are on campus. All right? And to do this, I'm going to talk about rethinking GPA. So GPA is one of the very few numbers we calculate for every student on campus. It plays a major role in their own self-conception of success and in our conception of their success. We use it in a very detailed way. So at Michigan, we have these 3 levels of distinction. They are determined down to the 1,000th place, right, in your GPA. Like, we treat that last 1,000th place digit like it matters, you know? But we know, as scientists, that a simple average of grades can't be the best estimator of anything, because we know grades are used in such different ways on our campus. First of all, there are very big variations in grading philosophy by department and by course and by instructor, right? Many people believe they're teaching courses to mastery. They give out high grades to most of their students because most of their students accomplish everything they ask them to do, and there's nothing wrong with that. In other places, people think it's their job to rank order the students in some kind of very aggressive way. They have a different kind of goal. I actually think they're kind of wrong in aiming to do that, but that's what they're doing. The fact that they are so different across different disciplines means we shouldn't be averaging these things together. There are other reasons as well. Of course, courses vary in difficulty. Some courses require very different kinds of efforts from students. Courses also vary quite a lot in the students who take them. So the people that you're actually taking courses with vary a lot. So we've been thinking about whether we can, well, there's one way you might solve this problem that will never work because it's been tried for 100 years. You can try to force people to give out the same grades. It won't work, but it shouldn't work either because people have different reasons for giving out grades, right? And I think that's sort of okay. So instead, we want to use the existing data to come up with a more nuanced estimator of student success. Now, to give you a sense of why we want to do this, this is a figure that displays for a whole bunch of majors, departments, what is the average grade they give out in their courses. The y-axis is the dispersion in the grades they give out in those courses, which is put there just to give you, just to spread it out really as much as anything. You can see that the average grade given out by department varies by 25% by a full letter grade on our campus. And yet we average these together as if they were the same. I'm not sure you can read all of the labels, but you can probably guess that the one on this side is math. The one on the other side is ENS. That's ensembles. It's marching band. There's really nothing wrong with that. But it is wrong then to average that grade with all the other grades and treat it as if it was the same. That would be kind of foolish. So there's this huge variation. As I mentioned earlier, I really like looking into the history of this. It turns out that back in 1908, a man named Max Meyer wrote a paper in the journal Science about the grading of students. And in it, he has this great sentence: "The experiment started by the faculty 5 years ago must be pronounced a complete failure." That experiment is the institution of letter grades. And both students and faculty before now have felt it to be a failure. There's no uniformity of grading, but the greatest divergence. It has come to be admitted openly that a student who's anxious to win honors must be careful to elect his work under certain teachers and avoid others as much as possible. So this is a more than 100-year-old problem, and we probably should do something about it. All right, so what are we proposing? There are a couple of different ways we could go about this. One that's simple to understand is inspired by wins above replacement, a statistic frequently used in baseball. The wins above replacement statistic is designed to account for the fact that you might play on a team that's really good, in which case your team's going to win a lot of games whether you're there or not, right? So it means to account for the local effects. So we're proposing something called grades above replacement, and it basically does a very simple thing. Instead of calculating your absolute grade and averaging that together, let's compare your grade to the average grade in the class, right? If you take a course where everyone gets an A, all we'll be able to say about the students in that class is that they look like average students on our campus. That is not a bad thing to say, but it doesn't allow us to tell anything about them, right? All we know is that they look like average. If you take a course with a lower average grade, then it's possible for students really to distinguish themselves in either direction, right? So what you get when you calculate this number, take the difference between your grade and the average grade in the class and average that over all the courses you take. What you get is something that's nice and Gaussian and centered on 0, right? If we had a number like this instead of GPA, a student might have a reason to take a class that gives out a lower average grade because they would, in fact, be able to distinguish themselves in some way. Right now, they have no reason but that they might survive a penalty, right? So it would change the kind of scheme of the way people think about things. What happens when you calculate this? What I've done here, I'm not sure is the best way to display it, but let me explain. I'm showing distributions of this grades above replacement number for students who have low GPAs around 2.8 and students who have high GPAs around 3.6 and everything in between. If you look at students who have low GPAs, their grades above replacement numbers are all less than 0. These are below average students on our campus. But some of them, even though they have a really low GPA, are pretty close to average students on our campus, because they got that in classes that were really tough classes. And some of them are much lower. If you look at students who have the mean GPA, they're mostly around average on our campus, right? But some of them are actually, even though their GPA is the average GPA, they're quite a bit better, and some are quite a bit worse. And the same is true at the very top. High GPA students are almost all above average. Of course they are. But some of them are very much more above average than others. You get that 3.8, there's an easy way to get it, and there's a hard way to get it. And this allows you to acknowledge for that. Okay? This system has some advantages. It's very simple. I kind of like that. But it has a drawback, too. It assumes that the students in every class are the same across the institution, which the data shows us clearly is not true. Stronger students are much more likely to take difficult classes, or let's say classes that are presumed to be difficult. And ideally, we'd like to account for that as well. You can do that. I have a couple of strong econometric students working with me on this. So they've built a model in which you model every grade that a student has as made up of two parts. One part is the student effect. How effective is the student in performing in his classes? And the other is a course effect. What does the course do to everyone's grades? Then you have to build a giant matrix with all the students' grades in all their classes and estimate these effects. It's possible to do. It takes a larger than a laptop computer. But you can do it. And what it gives you is a student effect for every student, something that's a substitute for a grade point average, and a course effect for every class, which says, how did this class affect the students' grades in that class? So in other words, it tells you, did this instructor give out low grades when the students, in some sense, should have received higher grades? Or did it give out high grades when they should have received lower grades? Or was it about right? It's a measure of that, right? By comparing grades across all these different classes. So I'll just show you something about that course effect. That course effect number, what did the course do to students' grades, is shown on the y-axis here. The mean grade in the class is shown on the x-axis. So you can see that when low mean grades are being given out, it's mostly due to the course. It's not mostly due to the students, right? And when high mean grades are being given out, it's mostly due to the course. It's a choice being made about what grades to give out, not the nature of the students who are in that class that you're seeing. But there are occasions, like this one here, where everybody in this class got an A, right? But the course effect was 0, because those were amazing students. They've gotten A's in everything they've ever taken, right? So sometimes the course is not affecting the grade, but most of the time that's what's happening, all right? Okay, let me finish by saying something about the future for me first, and then at Michigan, and then for learning analytics. For me, there are many fascinating things that I'm really excited about in this. The gradecraft kind of idea, flexible, adaptive, and instructional design that allows for a lot of student agency and still lets us do really attentive assessment, that's an exciting idea. I taught my first gradecraft class last year. It was transformational. The idea that we can measure behavior and connect it to learning is really exciting, because I believe that learning happens because of doing. Students learn things when they do things. And what we need to know in our research is, what do you have to do in order to learn? And if we can figure that out in a more precise way, we'll be able to help students get there, to understand what it is they have to do. I still think the idea of being able to digest more information is very powerful. And there's a field called natural language processing, which attempts to use computers to read and draw meaning from text at enormous scales. And I think it holds a lot of promise for us to be able to make students write more and learn more from their writing. And finally, the last thing is what I just mentioned, the idea that we would like to develop new ways for students to understand and represent their experience. I would like to supplement a performance-oriented GPA-like measure with a breadth-oriented intellectual diversity measure, and maybe 3 or 4 others, so that students, instead of pursuing just one number, would have to kind of optimize a bunch of things, and they might end up with a great liberal arts education, instead of just doing what they have to preserve a GPA. Right? So I'm thinking a lot about that. At Michigan, we're working on data-driven tool development in the Digital Innovation Greenhouse. Learning analytics research is moving into a bunch of new areas, including our emerging Institute for Data Science. And in the larger sense, we're thinking about connections across the CIC to the Society of Learning Analytics Research. I mentioned the MOOC. We're also thinking about industry connections, because really one of the ways to get impact is to invent really great things and have the commercial world help us spread them. So we're thinking about that in a way that I didn't used to before. So to sum up, data and the future of education, we will have tools that expose information that enable everyone on campus to learn from the experience of everyone. That's kind of the fundamental thing that I think we're doing here. It used to be that a student, to learn about what happens on campus, would talk to their roommate and the people on their hall. And we all know how powerful that is for them, but it's pretty limited. We want it to be much bigger. So everyone will be able to learn from the experience of everyone. We'll all be able to explore what happens and also to represent what we do in more multidimensional ways. I hope we'll get to the point where everyone expects teaching and learning to be like this. Like they wouldn't expect that they would be in any class where someone wouldn't be looking closely at what was happening in that class. The unattentive traditional form of teaching, I hope, will fade, and people will expect higher education to be run like a laboratory. Every time we do something, we do it intentionally for a reason, and we check and see whether it really worked. And this transformation, the way it happens is by drawing inference from data. It's the way the scientific revolution happened. It's the way we make a lot of progress in the world, and I hope that it will play a role in teaching and learning in the coming decades. Thank you very much.
So, thank you very much, Tim. I somehow have a feeling your, what's a grade above replacement was higher than average.
I haven't gone back to calculate my own. We'll find out.
You gave us lots of food for thought. Deb, how flexible are we on time? Because I know we're out of time, but I bet you there are a lot of people who have questions. So why don't we take a couple questions if people have specific things they want to ask, even though I know we're just slightly going to the next time. But if you have, there's 2 microphones, so please identify yourself and go ahead.
I can hear you. Go ahead.
So I was not a math person, I'm just going to say that. But I did take data analysis in undergrad. I didn't do very well. So I was wondering, I had a couple questions. How were you using the dots? So you had tiny dots and then you had slightly larger growing dots to differentiate how well I think people were doing?
So you're talking about a figure that had different size figures on it. Those dot sizes are meant to represent the number of students who are represented by each dot, so that you can see at the edges there are not very many people, and in the middle there are a lot.
And then the other thing I was wondering, so does this GAR measure fail to actually account for mastery of skill?
Yeah, it really doesn't make any measure of mastery. It makes a measure of what grade you got compared to other grades of people in the class. So a crucial thing in all kinds of measurement is to always be very careful to say what you measured. Usually we measure something, we mean to measure something else, like the quality of the student. But what we really measured was what grade did you get. Yeah. So we should be fair about that and say it's grades above replacement. It's not learning, it's not brilliance, it's just what it is.
So how do we bring that in?
Well, I'm going to move to the next person just because we only have so little time.
And let me just say, I'll stay here afterwards. Anybody can come ask
so
more
sorry
questions.
to cut you off, but I just want to get a little bit of variety of voices.
If you had to make a
Introduce
prediction, oh sorry, Sandra Laughlin, I'm the Director of Innovation and Learning at the Smith School of Business. If you had to make a guess about the timeline for implementation of something like grades above replacement or a more sophisticated algorithm, what would be your best guess?
That's a great question. I think I have certain strategic approaches, one of which is to not replace GPA, but to supplement it. So I think we can add new things that we might report for students. They might or might not be on the transcript. We might provide another way for them to represent that number, to get it and put it on their CV if they want. If people find it useful, then I think it will spread pretty fast. If people don't find it useful, then it won't.
5 years? One more question?
I think we might have something in 5 years, yeah, for sure. It's not crazy.
One more question?
Hi, I'm Karen Gadan from Biology. Thanks for your talk, and I appreciate that you recognize students as the consumers, the primary consumers for this kind of data analytics. And I've noticed, I've been somewhat surprised to find that my students have a lot of access to some of this data through sites like Koofers and other sites, and I'm wondering what you see the role is. Are those partners in this effort? Are they competitors? And how are they using that data now?
Yeah, that's great. So there are a lot of sites that mean to aggregate data about what happens on our campus and give it to students. Rate My Professor is probably the first and most obvious example, but there are these places like Koofers that are asking students to self-report grades. What they do is they average the self-reported grades of the students who bother to self-report. So what they're doing is providing our students with data. Our students love it, they're excited about that data, but it's crappy data, right? So I think they help push us to release better data to the students. I think we should be giving them good data so that they don't run off and use bad data.
Thank you very much, Tim. And I will say before you give applause, I bet you I'm going to organize a Maryland meetup to take Tim's MOOC. So look for email from me in a month or two, and we will all, or as many of you want to carry on this discussion, we'll have an opportunity to do that. Thanks, Tim.
Thank you.